Yo, Kevin, ready for the marathon tomorrow?
Of course I am. That's why I brought this. This is gonna put you in your place tomorrow.
Bro, are you serious? This is gonna win me the marathon.
Wow, you're stupid. You can't eat all that and expect to run tomorrow. You're gonna be way too full.
You're an idiot. You're never gonna have energy to run a mile.
We'll see.
During race day, Kevin starts sprinting while Mike remains jogging. As Kevin sprints, his body needs to utilize energy in order for his muscles to produce the adequate amount of force to drive him forward. The energy that the muscle uses is known as ATP. ATP stands for adenotriphosphate. This nucleotide contains a large amount of chemical energy stored within its phosphate bonds. When it is broken down, the muscle uses the stored energy in its metabolic processes. His body immediately starts to undergo a metabolic process known as glycolysis. Glycolysis simply means to split glucose. Glucose in the bloodstream starts out as a 6-carbon molecule, which then undergoes several phases to produce ATP. In the first phase of glycolysis, a glucose molecule will enter the cell's cytoplasm. This is the site where the glycolysis occurs. For each molecule of glucose, an energy investment of 2 ATP is required. The 6-carbon chain is then broken into 2 3-carbon chains known as pyruvate and continues on to the next phase. After the energy investment phase, we then move on to energy generation phase. In the next phase of glycolysis, the 2 3-carbon chains are modified in a series of steps that produce 2 ATP and 1 NADH. The 2 3-carbon molecules also turn into pyruvate. This happens twice for every 1 molecule of glucose. As Kevin continues, he clearly starts to show a sign of exhaustion. And as he runs, he comes to a crossroad. Down one road, titled Oxidative Phosphorylation Marathon continues this way. And the other road reads Anaerobic Respiration Shortcut. Kevin decides he needs to take the shortcut.
Since Mike has had more carbohydrates, he has more to burn off. This will take him through to slow glycolysis. After he went through fast glycolysis, he's going to transition into slow glycolysis. His first stop is generating the acetyl-CoA. Pyruvate, which is what his body formed earlier from fast glycolysis, will now form into acetyl-CoA. Mike receives 2 acetyl-CoAs per 1 pyruvate molecule. Once Mike's pyruvate turns into acetyl-CoA, the acetyl-CoA will go into the Krebs cycle. The Krebs cycle is a cycle of enzyme-catalyzed reactions in living cells that is the series of reactions of aerobic metabolism of carbohydrates, proteins, and fatty acids. Mike continues his run to his next stop, which is the electron transport chain. This is where the NADHs and the FADHs come into play. These molecules are hydrogen carriers, and the whole process occurs in the mitochondria of the cell. Pairs of electrons from NADH or FADH are passed down in a series of steps through several complexes to produce ATP, which is the currency of life. Oxygen is essential for this whole process because it is the final electron acceptor in the electron transport chain. If the last cytochrome was not able to accept more electrons, the ETC would stop. This is the reason we breathe oxygen. For every 1 NADH, there are 3 ATP formed. For every 1 FADH, there are 2 ATP